So today today let's look at the last type of a sequence or sequences, which is exponential sequences. And I want to say an exponential sequence is a sequence that does not follow the first, second, and third difference rule, which are the rules that we've been using since we started looking at sequences. This one is a different and unique kind of sequence. So what it's got is what we call a common ratio between consecutive terms. Now, I want to explain what I mean by common ratio. So the common ratio between two consecutive terms is found. So for example, let me call a common ratio between the first two terms to be T1, all right? So the common ratio between two consecutive terms is found by dividing 39 divided by 13. If we do this nicely, you'd find that this is going to give us a 3. So for this type of a sequence, it will always be giving you 3, regardless of what type of terms you pick, for as long as they are consecutive. So for example, let's say another common ratio called T2 is what we get when we divide 117 divided by 39. So if you do 117 divided by 39 or 13, this would give you 3. So when we say an exponential sequence is a sequence that has got a common ratio which is the same, this is what we mean. We mean like when you divide two consecutive terms, you will be getting the same constant or the same number. In this case, we are getting a 3 and a 3. So a 3 is what we call the common ratio of this given sequence. So we normally just write that as T equals to 3 to mean common ratio. So now the question says find the nth term and the next two terms of the given sequence. Now, if the given sequence is exponential, the nth term is of this form here. I'm not going to be giving you theories on how we come up with these formulas here, but for now it's just important to take note of how or in which form the nth term would be. Now the t is the same common ratio, which I'm going to just say CR, and then the a is some constant that we'll be finding soon, and then Tn stands for whatever term you pick and then its position n. So in this case, to say find the nth term and the next two terms of the given sequence, all we do is find the common ratio. Now the common ratio is this which we've already found, which is t equals to 3. Upon doing that, what we need to do now to complete the formula is Tn is going to be equal to a times the 3 to the power of n. So now this is how our formula is looking, but we still need to find what a is. And how do we find this a? So to do that, you need to pick a term, any of the terms here if you want, maybe 13, 39, or 117. Now that term, if you pick it, you also need to pick its position, which is going to be, in this case I'm picking 13. Then it means n is equal to 1 when I pick 13. So I'm going to put 13 where there is Tn. And so it would be 13 equals to a multiplying 3 to the power of 1, because this one is the position of this 13 that I've picked in our given sequence. So if you do this nicely, we are trying to find a. This would give you 3a equals to 13. And if you divide by 3, this would give you 1. 1 times a gives you a, to get 13 over 3. I'm leaving my answer as 13 over 3 because if I divide it by 3, it's going to give me a recurring decimal, and it's not a very good idea to be doing some premature rounding off. So we're just going to say our a is equal to 13 over 3. So now we need to complete this formula now. So we're just going to say, therefore, our nth term Tn of this exponential sequence is going to be 13 over 3 times 3 to the power of n. So if we do this nicely, if we do indices, we'll start writing this in a different form. So for now, let's just leave it like this. So it means our nth term formula now is this one here. All right, if you are one who's been exposed to the South African syllabus, or IB syllabus, this can also be written as Tn equals to 13 dot 3 to the power of n, and then equals to over 3. So this dot is not point, it stands for multiplication. So what we need to do now is to prove whether this formula works before we can find the next two terms here. So doing that, we're going to say if n is equal to 1, it's going to be 13 times 3 to the power of 1 divided by 3. So right away you can see that T1 is going to be that, and that is going to divide, giving you 1 there. 13 times 1 would give you 13, which is our first term there. If you want, you can also check on the second term. You say when t is equal to 2, when n is equal to 2, it's going to be 13 times 3 to the power of 2 over 3. Now if you do this nicely, this is going to give you 9. 9 divided by 3 gives you 2. 3 times 13 gives you 39. So you can see that our formula is working nicely. So it's safe to conclude that this is the nth term here, the one that we've written here. So I'm just going to create space somewhere. I don't know, no, I don't need to, it's fine. So let's just find the next two terms here. So finding the next two terms here would mean n is going to be equal to 4. All right, so if you do nicely, our T4 there is going to be 13 times 3 to the power of 4 divided by 3, which is now going to give us 351. So what should have been here is 351. We can also find T5, which is the term that is supposed to be there. It's just going to be 13 over 3 times 3 to the power of 5. If we do that nicely, we are going to find 1053. So these are our terms here. So if we look at them nicely here, you notice that they also obey the common ratio rule. If you divide 1053 divided by 351, you would get your t to be equal to 3. So this is very important that you guys take note of. And please, if you are a teacher, recommend this page to your students if they are doing Zambian syllabus. If you are a student, recommend this to your colleagues. This is free education for you guys. You can always like and share my page. I've also opened a YouTube channel which is also called Math Antenna. So guys, I'm posting the second video, which will be the last video on exponential sequences. Please find time to watch it, share, and subscribe to my YouTube channel. I'll be posting the link also to my YouTube channel so that you guys, in case you are not a Facebook fan, can just go and watch the short videos on whatever topic you want to do. So guys, thank you very much. Watch out for the second video on exponential sequences, which will be the last one. And if you've got questions, please just send them through. We'll make a very special edition to tackle your questions. Teachers, please recommend this to your students. It's free education. There's nothing to pay. Everything is done for your students. They are not going to be paying anything. This is just meant to help them and help you as my fellow teachers. Thank you very much.